What's up everyone? Today we are spotlighting something fun and useful. A Raspberry Pi Pico 2 powered 64 by 32 RGB matrix panel setup. By the way, it's not a miniature version of your favorite dessert. We are not baking pies here, just baking up some awesome LED magic. Here we have made a simple setup where the Pico 2 is linked to the display's input I/O port. We have also included a power module that utilizes a 12-volt adapter to power the display and the Pico. The goal was to create a Pico 2 driven matrix setup that would make working with the matrix panel simpler, because all we would need to do is plug in the USB cable to the Pico and input our code. There would be no need to rewire anything or swap out any connections. We created this configuration in order to utilize this matrix in a future project that will be a portable gaming device that runs Snake Game. We currently have prepared a demo sketch that initializes a snake in the center of RGB matrix and causes it to travel. The snake's direction of movement changes randomly at different points in time. In this setup, we have included a DC-DC buck converter board that we have previously designed to address the issue of matrix panel high power consumption and the Pico inability to power the entire panel via its USB out pin. The 12 volt from the adapter is stepped down into steady 5 volt 3 amps using the buck converter board, which is sufficient to power the Pico and drive the matrix panel together. We created a frame-like part that is fastened to the rear of the matrix panel to keep everything orderly. It secures the Pico 2 circuit, the buck controller board, and the DC barrel jack. In this project, we are utilizing the 64 by 32 RGB matrix panel, which consists of 2048 RGB LEDs arranged in a 64 by 32 grid, which produce vibrant text, images, and animation. This panel is controlled using a Hub 75 interface, which relies on multiple control pins, including RGB pin, address pin, a clock pin, data latch pin, and output enable pin. Using 5 volt source, we can drive this display, but there's a catch. The current draw can vary significantly depending on the number of LEDs lit and their brightness level. A fully lit panel can draw substantial current, so a power supply capable of providing at least 4 to 5 amps is recommended. Additionally, by utilizing the included in and out connectors, we can connect multiple panels in pair and form a chain. With Pico 2, we are currently using a single panel that can power 2 or more displays without causing any issues. As for sourcing this matrix panel, we got it from PCBWay's gift shop. PCBWay Gift Shop is an online marketplace where you can get variety of electronics module and board for their genuine price. Or you could use their PCBWay currency, which is called beans. You get beans after ordering something from PCBWay as reward point. Or you can get them by posting any project in their PCBWay community. You guys can check out PCBWay if you want great PCB service at an affordable rate and low price. We utilized one of our previously made Pico expansion board, a straightforward circuit that resembles a prototyping board with a Pico footprint in the middle to set up Pico 2. First, we attached two 20-pin female header connector to Pico's footprint 2 pads. Next, we attached two 8-pin male header pins to the board's left side. The purpose of these male and female header pin is to connect Pico and the LED matrix I/O connector together. We soldered all the male and female connector leads that were added to the expansion board from the circuit's bottom side using a soldering iron. By following this provided wiring diagram, we begin the wiring process by first using a jumper wire to connect the ground pin of matrix I/O pin to the ground pin of Pico. And then the rest of the pins are soldered together. We are using one of our earlier projects, the Super Power Buck Converter board, which is a power module that could provide voltage ranging from 3 volt to 12 volt depending on the source supplied. The input voltage in this instant is 12 volt and the output voltage is 5 volt. This module is based around the IP6505, a step down converter with an inbuilt synchronous switch that can handle an output of 10 amps for fast charging protocols. We connected the output of the buck converter with the Pico's 2 V bus and ground pin, which will be used to power the microcontroller. We created a frame that is fastened to the rear of matrix panel with M2.5 threaded insert on the matrix. This frame was designed with a DC barrel jack holding section on the one side and the Pico 2 circuit and the buck converter module on the other. After placing the frame on the backside of the matrix panel, we install 6 M.2 bolt in the mounting holes to start the frame assembly process. We use a screwdriver to tighten every screw, securing the frame with the matrix. Using a soldering iron, we join the buck converter's output pin to the matrix board VCC and ground to start the matrix assembly process. The DC barrel jack which is connected to the buck converter's output side is then disconnected, and then it is fastened to the mounting holes on the frame section. We then connected the VCC and the ground of DC barrel jack to the buck converter's V-in and ground port. We attached the buck converter board to the frame by positioning it in place and then using hot glue to secure it in its location. The CON16 ribbon cable connector, which is included with the matrix board, is then connected to the input connector of the matrix. The matrix and the Pico are then connected by this CON16 connector. Two M2 screws are then used to secure the Pico breakout board in place after it has been positioned over its location on the frame. After the matrix setup is completed, we connected the Pico to our computer to upload the code and plug the 12-volt adapter into the matrix DC barrel jack socket to begin the test procedure. We made this simple Hello World sketch, which initialized the RGB matrix to display a variety of colorful animations, including gradient, diagonal lines, moving shapes, expanding circles, and scrolling text to demonstrate the matrix graphical capabilities. Make sure to first install the Adafruit Proto Matter library before using this sketch. Now, in order to take this matrix setup to the next level, we created our own code that would run on our matrix panel by porting the Game of Life code that was obtained from an example sketch of the FastLED library. The British mathematician John Conway created this amazing cellular automation known as the Game of Life in 1970. It's a 0-player game, which means that no additional input is needed. Instead, the game evolution is dictated by its beginning conditions. The game will start with a random configuration and then restart with a new random configuration after it halts. And yes, this setup is Turing complete. This project ended with a functional matrix setup that is simple to work with due to the Pico 2's implementation and the addition of a DC buck converter circuit on the rear that enable the user to power it directly from a 12-volt source, thus resolving the power source issue entirely. This project turned out well overall, and I'll be returning with the Snake gaming console, which will dive deeply into the construction of the gaming device. In addition, we appreciate PCBWay's support of this project. Visit them for a variety of PCB related services such as stencil service, PCB assembly services, as well as 3D printing services. Thanks for reaching this far, and I'll be back with a new project pretty soon. Peace out.